Good morning to all. Today we are going to discuss about interrupt programming. In the previous two sessions we have seen what are the interrupts, type of interrupts, interrupt service routines, what are interrupt cycle. We have discussed about the various interrupts. So before going to the programming part, just a brief what the 8086 microprocessor will do if any interrupt occurs. So as you all know, interrupts are of two categories, which are external interrupt and internal interrupt. External interrupt, we can give an example as keyboard interrupt. Internal interrupt, we can give the example as any instructions given by interrupt in the program. Okay, so what is interrupt cycle? So it stops if the CPU is executing a program, if it is in the some instructions, if an interrupt occurs, whether it may be a hardware or software, it stops the current execution, nothing but completes the current execution and pushes the flag register onto the stack, pushes the CS on the stack by clearing the IF, by clearing the trap. It pushes the IP of the ISR and the ISR program will execute. After execution in the program, if irate is there, it returns to the interrupt and again pops the CS, pops the IP, pops the flags and continues the normal execution of a program. This is how 8086 will be using its interrupts. So while programming for any type of interrupt, the programmer must either externally or through the program set the interrupt vector table. Set the interrupt vector table for that type, preferably with the CS and IP addresses of the ISR. So as we all know, we have type 0 to type 255, which type the interrupt has occurred. So correspondingly CS and CS address, which is the code segment, and the IP address of the interrupt service routine, we should able to know. The method of defining the interrupt service routine for program as well as hardware interrupt is the same. The method of defining the ISR for hard software as well as hardware interrupt is same. So how the execution sequence will be? So if we are writing the program, it's starting by an assembler directive, assume CS code, DS data segment, some data you are mentioning in the data segment, data ends, then going for code segment, start some instructions. If in the instructions we have an interrupt occurred, which is int 09H, which is an interrupt, so it stops the execution here. It executes this instruction, goes to the interrupt service routine, which is 09H. It finishes this interrupt service routine, type my 09H. If you have if you have irate, then it comes back to the code and it ends. After completing the execution, it ends and ends. So this is how your interrupt programming will be. Nothing but you are stopping, or you are for a moment you are stopping the current execution, going to some other program, executing it and again returning back. That is how the interrupt will be programmed. So after completion of the execution of an interrupt, it comes back to the original program and will be performed its execution. So interrupt programming, transfer of control for the nested interrupts. If we have multiple number of interrupts, then depending upon the priority, which we have seen in the previous session, that NMI has highest priority, then we'll be having a interrupt request or divide by 0, whatever the error. Depending upon the interrupt priority, it will be programmed. So as I told you in the previous session, for an example, if any int 0ah, for example, in the main program occurs, so it goes to the ISR 0ah, it begins. And suddenly here, while executing the ISR of 0ah, if int 0bh comes into existence, then it stops execution and goes for ISR 0bh. So after finishing this, again return back to the int 0bh, sorry, ISR 0bh, ISR 0ah, it completes, again it ends that ISR, then it goes to the main program. So in this way, the interrupts will be handled if number of interrupts are in a nested fashion, depending upon the priority wise. So this is what the interrupt programming is. We will see to some programs. I have done already 2 programs, which includes the proc procedure, which we will be studying in the next session. Procedure. Okay, I have used a main proc for, so we can remove this, directly write dot code, it will execute it. Right? So simple program, nothing but we have a string in that defined byte. Programming is fun, and it will be checking whether your data is being displayed until the last word will be your dollar. Right? So the first 2 lines are similar to, I will show you with the emulation. Yeah. So it will start from move x comma @data, because these are all what? They are all not executable statements, nothing but they are all assembler directives. So first step, move x comma 000714. So I will click on view, go for memory. Here I will type 0714. And 0 and update. We will get the data segment which we have stored as programming is fun and its opcodes. The next step is move ds comma x. Now x value will be stored in dx. Then we'll be giving the move ah comma 09h. So this is one of the interrupt which is being used for going for the address. We are using a function called as load effective address dx comma string. So in the dx, string is in from 4 zeros into 21h is to display the character or display the string. So I will run this. It goes to the DOS, so you can see here it is displaying programming is fun. So here it executes to display the characters programming is fun. The next line it goes for 4ch, which is terminate the program. Again in 21h it will display or end the program. So this is how here various types of interrupts are being used. So it is stopping here, going for that interrupt, displaying the output, again coming back, terminating the program, and then displaying as terminated the program. So this is how, when the series of interrupts will be occurred, you need to program the interrupts. Similarly, we'll go for the next, which is also similar to the previous one. We are using a proc procedure, which we can call in C as function. Whenever we are calling a function, it will go for that function, execute that function, again return back. Right? In a similar manner, proc is also a one type of function. Whenever we are calling a procedure, it goes to that procedure, execution, done, again returning back iproc or return proc, it will return into the main and execute the data. So I will show you the program with the help of emulator. Single step, you see here move x comma data, so which is here 00720. So going to view memory 0720 and we'll start from 0 update. So you can see here I have some 50 values which are being stored with the dollar, 50 duplicate values up to dollar. Okay, so what the thing is, I will be giving my input, what are the inputs, until it asks if Q I type and compares with the Q, it stops. This is what the program is, right? So I will go for single step. Offset of string is being loaded into CX, then move h comma 01h, then in 21h. Now it is waiting for the input. See here, waiting for an input. So I will enter some A. So I have go for next single step, compare AL with A. Small a is exit code is 61. So 61 it is compared with Q. If it is same, if equal, go to loop 1. It is not equal, then it goes to next. Next, increment SI, jump to loop 2, again move h comma 01h, in 21h, now waiting for an input. So input I will type B, so go for next step. B is not equal to Q, so it will go, it not loop 1, it goes to next line, SI, inc SI, jump L2, move h comma 01h. Now I am waiting for an input, so here I will press Q. Now I will go for single step. Now compare AL with Q. Now here it is equal, so it goes to loop 1, move h comma 09h, move ds comma offset string, in 21h, it will display the screen as AB. So before Q, whatever the data you want, up to that it will display. So this is how your interrupt works. So this is how you will be using your interrupts in order to display the screen, in order to whatever the interrupts you require. I guess all of you are clear with this. So this is all about interrupt cycle, interrupt programming. Thank you.